Hi friends, welcome back to the Programmer Guide YouTube channel. Today I am going to discuss about the sequential streams versus parallel streams. What is the major difference between the sequential and parallel streams? You wanted to know, it is a very important question for the interview room. So coming to the sequential streams, we have seen so many examples and so many classes, right? We have covered the intermediate methods and terminal methods and streams. In that, right, I have given so many examples, even though, right, since it is a time to for differentiate the between the major differences. Okay, so by default any stream operation in Java is processed sequentially unless explicitly specified as a parallel. That means any Java program or any stream in the Java is going to be work as a sequentially. Okay, so since it is a sequential, right, it is going to be execute in the single core. Okay, so suppose you are having the i9 processor, but there is 9 cores of processor you are having, but even though, right, sequential streams are going to be execute in the single core. That means in the sequentially thread 1, thread 2, thread 3, thread 4. Once thread 1 completes, then only it is going to be start the thread 2 until unless it is going to be wait state. Okay, so sequential streams performs operation one by one. That means thread 1 completes, then only it is going to the thread 2, thread 3, thread 4. Such a way it is going to be executed. If you see the very important pointers of this, right, sequential stream will run single core of the computer, so that we can call it as a single thread processor. Sequential streams invoke by using the stream method. If you see this example, right, I mean we have seen so many examples, even though I am showing another example. Okay, see, sequential streams are going to be called as a by using the stream method. Okay, so let me execute this program, right. Even you can see the order is going to be maintained. See, A for XYZ Java 8 computer portal. Okay, so such a way you can call it. Suppose, right, sequential stream will maintain the order, and sequential streams performance is poor. Execute in the sequential, right, performance is going to be bit less. Okay, it will execute only single iteration at a time, just like a normal for loop. That means streams are going to be execute in sequentially in single iteration at a time, like A is one time, for is one time, xyz is one time, like a for loop it is going to be execute. Okay, each iteration waits for currently running thread to finish the execution. Suppose, right, if you are having the thread 1 is having operation like uh, I mean it's like employee data need to be get and need to find the maximum employee data. So after that you need to have another concatenation of method, I mean intermediate method joining is possible, right. So then only it is going to be perform the another, until unless second thread is going to be in wait state. Okay, creating sequential streams are not cost effective in large data, because no need to split the data and merge the data. What I meant to say is, right, suppose if you are working with the parallel streams, the data is going to be split and the merging process is going to be happen. But whenever you are working with the streams, right, the data is already in sorted mode, so you no need to split and merge. And since it is executing in single thread process, right, so there is no need of merging also required. Okay, streams are more reliable and less error error prone, so it is very good choice for large scale programs or complex projects. Okay, sequential streams are platform independent. Suppose the stream whatever you have executed, right, the same data is going to be output which whatever the operating system you are going to be execute. Now coming to the parallel streams, right, parallel streams are going to be utilize multiple cores of the processor of the CPU, so that multi-core processor instance performance is going to be increased. Since all data is going to be divided into the small set of data, right, so performance is going to be increased. The order of execution is not in our control, so the output is going to be unpredictable. Okay, so the more important point is, right, here you need to focus on, say, core 1, core 3, core 4, core 5 is there. So thread 1 is running on the core 1 and thread 2 is a core 1, thread 3 is core 5, thread 4 is core 2. Such a way it is going to execute parallelly. So please watch my previous video, parallel streams, right, you will get more understanding. Parallel streams utilizes multi-cores of the CPU. It invokes by using the base stream dot parallel method or collections dot parallel stream method. So let's see the example, right? So I mean, how you can call the parallel methods, parallel streams. See here, right, you are having the parallel by using the base stream. See, int stream is the subclass of base stream. So in the previous video I have explained that, right? So you can watch there also. See, the data is unpredictable. I have given the range of the data 1 to 15, but the finding the even numbers is unpredictable. Data has been displayed, and also you can able to call by using the parallel method, parallel stream method. If you want to, I mean, it invokes by using the base stream or collection dot parallel stream. Relatively performance is high with respect to small amount of data, since, right, performance is going to be high with respect to small amount of data. If it is a large data, right, splitting the data and merging the data, it is going to be cost effective, right? So that small data, it is performance is very high. Parallel streams does not care about the order, right? If you want to maintain the order, you need to use the for each order method. See here, right, there is no order maintained the output. Okay, if you want to maintain the order, right, in the same example I will show you. Okay, filter dot for each ordered. See, now you can find the order of execution is similar. See, 2, 4, 6, 12, all the even numbers you find based on this example. Okay, so why I'm showing with example, right, it is a proven concept, so then you will understand more. It operates multiple iterations simultaneously in the different cores available, right? In previous section we have explained, like the streams are executing in the multiple cores in simultaneously. Whenever you are executing, right, it will wait only when CPU is, it waits only no cores are free in CPU. That means you are already occupying the 10 cores, I mean 9 cores. So only all the threads are executing parallelly, right? So if there is any non-executable threads, right, then no core is free, then only it is going to be wait, otherwise it will execute as it is. Okay, creating the parallel streams are very cost effective in large data, because, right, the data is going to be split multiple times and merge the multiple times. It is a cost effective, and also the data is not going to be organized, right? If you want to organize, you need to call the dot for each order method. So in that case the data, I mean, processing time is going to be high. Okay, parallel streams are less reliable or error prone. So parallel streams are suitable only small projects are. Okay, parallel streams are platform dependent. Suppose the order of data executed, right, without calling the for each order method, so the data is going to be independently changes from one system to another operating system. I mean, it is going to be change the one operating system to another operating system. All the differences I have explained, right, as of now. I maintain the table format, right, it is going to be more useful for you. You can go through these sequential streams and parallel streams differences, right, so you can understand more. All the data are, I mean, differences already explained, so you can go through and you can remember this for the interview purpose. Okay, if you like the content of the video, please like my channel, subscribe my channel for the more videos. Thank you very much for watching this video. Bye bye. Take care of yourself.